Today we are going to learn on working with them. So to start a member, first we need a join. So for that, I would come over here, create my first joint. Then I will create another joint at 10 meters. So let me take a look at the XY plane. Okay, this is XY plane. It's at 10 meters. Now I am going to divide. So I'm going to make another joints in between so that I will get a joint at a distance of 2 meters. So for that I would create number of 4 joints over here. Now if I look, the distance is 2 meter. Now I want to create a grid. So for that I would come over here, translate and rotate, select these joints. I will translate by 2 with duplication. So I will go for duplication and I want to have a duplication of 5. So let's see, now this is a 10 by 10 grid. Okay. Now to assign members, first what we want is, we'll come over here, click add. There are 2 approaches. First, people create the member, they will add property and sessions, keep it ready, and then assign. The second way is to come over here, directly assign. So if I come over here, it will ask me for join A, join B, and in the group label, I can specify a group label BM1. So if I select join A and then join B, then click apply, it will assign a member. It will assign a member over there. Now, if I want to add more members, so I want to repeat the step again. So either click apply or right click. So similarly, I can do like this. Or if you want to make it faster, what you can do is you can click add immediately. So once I select join there, and instantly if I select join B, it will create a member like this. Now, if you notice, there is something called type of add. So there is individual and string. So till now we used individual option. Now if you go to string, what happens? Now if I go to string, it will create a continuous member. So let's say I select my joint A, then select joint B. I will create the member. Now I don't want to select my first joint because the second joint I selected, it automatically becomes first joint. Now if I click on this one, it will add members like this. So it goes like this. So this is the option called string. Okay. Now there are few more options with respect to the members. There is like express. Let's say if I want to create an express over there. So for that, what I want to do is I can come over here. So I want to give a name to the center joint, and then I want to select the first joint of the through member. So it will be the through member. Second joint for through member. Then first joint of the non-through member. Second joint of the non-through member. And here I can assign, if I want, I can assign 2 member properties. So what I am going to do is, for through member, I will select BM1, and non-through member, I will select BM2. And if I click apply, it will create a X joint. Now let's say if I want to create a K brace. So for that, what I want to do, I want to do the same. First, I want to select the end joint of the code and other end joint of the code. Then one joint of one brace and the joint of another brace. And here, if I want for code, I will keep BM1, and for the other one, I will keep it BM2, and click apply. So see, I have a code with BM1 and the braces with BM2. Now, before assigning the member, or maybe we can directly go to assign the member. So once we make members like this with some group naming, you can come over here in the property, and in the member group, these groups will be there in the undefined group column. So to define the group, what we need to do, select any of the label name and then click on add. So here we will get a pop-up. So in this pop-up, first thing we have here is segment. We will discuss about segment later. At the moment, we will keep full member as one segment. Now, here we need to provide the section label. So this box will define the material properties, and this particular part will define if it's a what type of beam. So we can directly take it from the section library. So if you want to take it from section library, you can click on library. Now I am going for a wide flange. So from the wide flange, I can select any type of wide flange. Maybe let's say I go for W1677. All the section properties are over here. And here I can select E, G, the default values. Now let's say if you are working with the 345 or 355 MPa steel, you can change it over here. And rest of the things, even if you don't apply, it's fine. If you want to change the color, you can change the color. I'm not changing color now, and I click apply. Now if you want to see that in 3D, you can come over here and toggle the wireframe option, so you can see this particular member in 3D. Now we defined the property for BM1. Let's do the same for BM2. So for BM2, I am going to make only one change. Maybe I will make two changes. So first thing is regarding the size of the wide flange. Earlier ours was W1677. Now what I am going to do, I am going for some smaller one. Let's say W1290. And I'm going to change the color of the beam. So I will select a green one, and yes, so this is my green. So I hope you can see over here. Now let's say if I want to have some offsets of this member. So if you look over this beam, when we take the beams, and its center line always coincides as a default with the joint plane. Now let's say if I want to have an offset, so I can come over here in the member, use offset, and here I can either go for global or local, or I can use like top of the steel. So what happens with top of the steel is the top of the steel will offset to the joint level. So if you want to see, you can just click over here like this. It will offset to the joint level, or you can go for bottom of the steel. So if you do that, it will offset like this. And now let's say if you want to give some I'm going none, and I am going for some global. So global, if you look over, this is the global axis. So my beams and the joints, everything is in the XY plane, and global axis Z is vertically upward. So if I want to give some sort of offset, let's say I give a offset of 3 centimeters. So I want to give at both ends in this case. So it will offset little bit like this. So now there are two coordinates when we work with the beams. So one is the global coordinate, another one is called the local coordinate. So if you activate this one, this is the local coordinate. So if you look over here, what happens is my Z is anyway, it's aligned with the global Z, and X is always along the beam from A joint to the B joint, and this local coordinates are defined by right hand thumb rule. Now coming over here, now let's say if I want to give an offset in global or local, so I can go for local axis. I can do the same. Maybe I will give an offset of 6 centimeters, and I can go like this. So now let's say I want to make this one flush with this P, particular P. So for that, what I want to do is I will come over here. I want to select a reference P. Then I want to select the member to offset. So if I want to select multiple, I can click Control and click Apply. So what it would do is, here I select the option called Top Flush to top of the reference member. Now it got flushed to the top. Now let's say if I want to use this one, bottom flush. So for that, what I would do, I will do again select so this one, and then I will select these multiples and it will get flushed to the bottom. Now let's explore what are the other one. So stacked below the reference member. So for that, this reference member is my first member, second member. So it will stack like this. Now if I go for stack above, so for stacking above, I want to select the reference member, my other members, and I change to stacked above. It will go like this. Okay. Now what I'm going to do is I want to just keep it as flush. So what I would do, I would select again this one, click apply. It will be flush. Now let's say if you want to change the orientation of the beam, this beam, if you want to do the orientation change, so for that, what you need to do, so if you want to change the orientation, you come over here and just put the orientation angle. If I put 90 degree, it will orient the beam like this. Okay, so if I don't want, you can leave it. And coming over here, I am going to flush this member as well. So for that, what I would do, select reference member, my all other members, click apply. Now this one got flushed. Now the interesting part is how to split the members. So if I look over here, let's say I can divide the member in different forms, different ways. So for that, what I would do is I will come over here, divide. So in the divide, I can use a different options like this. Now let's say I will come over here, ratio. So I can divide these members with a different ratio. So let's say I want to divide by 50. So if I look at the distance, now the distance is 2 meters. Now let's say I want to divide it by 50%. So what I would do, I will divide the member. You can see two group names and you can see the length is 1 meter. Now let's say if I want to divide this 1 meter again by 60% from the joint A. So let's say 70% from the joint A. So that should be 0.7 meters over here. So this is joint A. So if I click over here, from joint A, it will have 0.7. Now let's say I am going to say from joint B 0.7, let's divide. So if I click on here, so this was the point B. From here, that's 70%. So this is working with the ratios. Now coming to the next part is working with the length. Now for working with the length, what I would do is I will come over here. So I can tell, okay, from A joint, make a division at 0.2 meters. So what it would do is it will create a division at 0.2 meters. So I can tell the same, maybe from joint P, create a division at 0.2. So it will create a division at 0.2 from joint P. Now there is another option. So it's one either Z coordinate, Y coordinate, X coordinate. So to understand this, now let's take at this particular joint coordinates. Now let's say I have this is X coordinate at 2 and another X coordinate at 3. Now let's say I want to create a joint at global X coordinate of 2.5. So for that, I would come over here like 2.5. So in the normal case, I want to create a 2.5 joint. Then I just want to plot, but this is in an inclined way. Now if I want to create a joint at 2.5, click on this particular member. So let's say I want to create a joint at 2.5. and click apply. So it will create a joint at 2.5 global X. Okay. Now let's say I want, so take a look at the Y. So this is the Y is 4 and this Y is 5. Now I want to create a joint at along this line at a Y coordinate of 4.3. 4.3. I click on this beam. Oh, sorry. What was my Y range? This was 4 and this was 5. So if I go for 4.3, it will create a joint at 4.3. Okay. So this is how you use the coordinate. Similarly, you can do it for the Z coordinate as well. Now this is the interesting part. Now let's say I want to divide this particular beam for 3 equal parts. So let's take a look. What is the length? It's 1.6. Maybe I will make it 4 equal parts so that it should be 0.4 meter each. So if I click on, it will be 0.4 meter. So it can do a number of, so let's say if I want to divide this by 8 equal parts. See, 0.05. It can do like that. Now coming to the next one, perpendicular. Now let's say I have a joint over here. I want to create a division perpendicular to this particular joint. So for that I want to select my perpendicular joint and the member to it. Divide, it will create a division at the perpendicular one. Now coming to the next part, intersection. Now let's say I have a joint coming like this, or I have members coming like this. So I will take PM2, I'm adding a member. So if you look over here, these members are crossing. Actually, it is not creating a joint. In reality, it should create a joint, but this is moving like this. This is wrong in case of the modeling. So now I want to divide these members. So for that, I can use this division by intersection. So what it would do is I want to select A line and the B line. Now you can see it was a single member BM2 going like this, BM2 going like this. If I click, it will create a joint and divide the members. Okay. Now let's say I have a joint somewhere. So from here I will create a joint. So in Y I'm creating a joint at 0.7. Now I have a joint over here, but it is not splitting this particular member. Joint is over there. So no type of transfer anything happens over there. So to divide that member with an existing joint, I should come over here, divide by existing joint, click on this particular joint, click on the member, divide. Okay. Now let's say I want to join these members. So for that you can use this option combine. So you come over here, click on the first member, second, then click on the second, click on first member, then control, click on second member and then apply. It will combine these members. So let's say if I want to do this one, I can select and right click. It will combine these members. So I can click this one, I get this one, I can combine the members like this. Now let's say I want to divide a member. I want to delete a member. To delete a member, if I want to delete these members, so I am selecting like this, the joint will be there. The member will get deleted, the joint will be there. Now, let's say I want to delete the joints. So I come over here and click on the delete and I will come and delete the joints. The joint will get deleted because no member was connecting to it. Now come over here and repeat this process. I will come over here, delete the joint, nothing happens. See, no zero joints deleted. Why? Because some members were connected to these joints. Now, if you want to purposefully delete that, yes, you can do. There is a way. For that, what we should do? You should come over here. So maybe this would be the best example. So if I delete this particular joint, all four members which share its property with the joint will also get deleted. So let's say if I click on this one and click apply, all four joints deleted, and sorry, all four members deleted along with that particular joint. So this is how you work with members. And now let's say there is another way about giving the property essay, right? Now let's say if you have some members that is not in your section library. Now you want to give that. So what you should do, come to property, come to section. So here you can define a section name. I am putting like section add. So here you can define any type of members. So you can have tubular, you can have white flange, you can have combat white flange. So you can see this tubular, this is white flange, combat white flange, box type, prismatic, cone, then channel, then T, then angle, concentric tubular. So this one will be very useful if you want to manually design a jacket like with the pile thing, but it will consider a 150 pounds of cubic foot of grout per cubic foot of grout inside this concentric tubular annulus. Now coming to the next one, it's the plate girder, then stiffened steel cylinders. Then what we have is different box, then tended tubular, launch runner, jacket plug, double angles, rectangular tube, double web plate girder, box plate girder, unsymmetric plate girder, the bulb for stiffness bun for the ship deck and all, then special launch runner. So if you want to have any of these sections defined, you can define like this. Now just for the simple one, I am trying to give some OD, let's say maybe 120 centimeters of OD and a wall thickness of 3 centimeter. I click apply. Okay, now coming to the group. So in the BM, maybe I will define a new one, BM3, add. So here in section label, I can directly go to model and I can select the section which I used. And I can select another color and click OK. So now that particular section is available for me and I can come over here, select BM3. Always remember, SACS always increases the name by one numeral, so you can get into trouble sometimes. So now let's say let me connect this one. So what I would do is I will click, that's okay, reset joins. So I'm going to apply as a string. Okay, so if you want to see this as a pipe, yes, you can have it as a pipe. Now let's say I want to change this dimension. For the pipe, you can directly take it from the property as well. So in the BM3, what I would do, I will come and click edit. Instead of selecting the section, I can directly select few things from here, like tubular, cone section, it's a plate section. So at that time, I need to provide my plate girder, or if you are selecting a section, it's better to keep it as general. Now I will come to OD. So instead of that 120, I am reducing it maybe to 30 and wall thickness to 2. So if I click apply, I can do that as well. Okay, so that's for this video. See you in the next video. with working on the magic of translate or rotate. Okay, thank you all. Bye.